Hello, my name is Dr. Cameron Jones, and welcome to today's live stream. We are going through unprecedented times with the pandemic, and most of us are probably wondering when life is going to get back to normal. We're in isolation. Many of us are deliberately quarantining ourselves and staying away from others because, of course, no one wants to come down with the virus-induced COVID-19. So, when is life going to get back to normal? Well, this is something which I, as a microbiologist, people ask me about this all the time. And so that's going to be the topic of today's live stream. And really, what I want to put up today now is preparing for a COVID-safe workplace. How are we actually going to do this? And what are some of these steps which businesses can get on the front foot now in preparation for preparing for this thing called a COVID-safe workplace? What's that going to look like? Because we're probably many months away from a successful vaccine or a or what are called non-pharmacological steps, which could reduce the severity of the disease. And so today I sort of wanted to review what is out there because a lot of people are suffering, and we all know that. So for example, what I want to put up now is a very interesting article which appeared in the Los Angeles Times overnight, and they were looking at the impact of the pandemic on the Hollywood film industry. And what they were looking at, they were taking a poll from some very well-known film buffs and people who are involved in the Hollywood movie industry. And one of them, Laurie Bolton, who was a location manager for Once Upon a Time in Hollywood. And this is no lightweight comment. That movie, in fact, took in $374 million. And they state that they can imagine when reopening occurs that there will be a strong niche for environmental cleaning companies with regard to testing and remediation in both prepping and restoring locations. Of course, another person, Jordan Horowitz, who was the producer of La La Land. Now, that movie alone took $446 million. He states that the film sets are going to need to be consistently cleaned and people will need to follow social distancing. So without a vaccine on the horizon and without treatments for COVID-19, the important heavyweights of the Hollywood film industry are suggesting that environmental cleaning is going to become absolutely fundamental to reducing the rate of COVID-19 cases and infections throughout the world. Now, I want to draw your attention to something which also appeared in Australia in today's Daily Mail. Now, I've put the article to the link that you can see what the journalist wrote in full, but our Employment Minister, Michaelia Cash, is calling on retailers to get ready to reopen and to create what are called COVID-19 workplaces. And again, she emphasizes, as does the journalist, that regular cleaning of high-touch surfaces is going to become routine and really mandatory. And businesses are now encouraged to create and get ready to prepare their businesses as COVID-safe workplaces for reopening, and they will have to focus a lot of attention on the high-touch items which could be contaminated with the virus which has been shed from either symptomatic or asymptomatic persons. Now, this leads me on to some fundamentals. And in order to get into the fundamentals, I want to tell you about the two types of transmission. Obviously, there is direct contact between persons coming into contact with droplet spread, shaking hands, for example, with someone who is contaminated, either they're symptomatic or asymptomatic, because as we all know, that many persons don't have symptoms, but can actively spread on the virus to other people. So this is the first method of transmission, which is called direct contact. But there is another method as well, and obviously we all understand the person-to-person contact, but there's something in microbiology that we call fomite transmission, and essentially that's coming in contact with surfaces which have been touched by other people, because we don't know who touched this before they put it into the cabinet, and in a sense we have to be very, very mindful to, of course, sanitize our hands after touching these unknown surfaces. So when the Senator is talking about making a business COVID workplace safe, they're talking about all those steps that that business can undertake to minimize the probability that people will come into contact with surfaces and the objects in particular workplaces that could have become contaminated by other people who have handled them. And so recently, I've been very active in publishing in the last couple of weeks, and I did a literature review of PubMed and also of one of the major preprint service, medRxiv, and essentially there were 16 articles as of approximately 2 weeks ago. The paper just came out 3 days ago, which focused on surface transmission, or how people worldwide, what academics are writing about this concept of fomite or surface transmission. And I'm going to review that here today. So here's the paper which I wrote, which came out just a couple of days ago. Here's the URL on the screen, so I'd urge you to download this and read all about this. But what I'm going to do is that I am going to go through the top 10 key points, because they're extremely valid to underpin this concept of how businesses should be considering dealing with surfaces that may or may not be contaminated. And the number one point that I want to look at, and again, these are from the 16 articles which I've summarized, and I'm just cherry picking some of the key points which I think are most important to get across. And so one of the articles was looking at hospital environmental hygiene, or how it's being monitored. And what they did is that they were doing something called surface sampling. And for want of a better word, that's the ability to actually sample a surface and determine whether or not there is COVID or the virus that causes this disease present on these surfaces. And what they found is that from the isolation wards, where patients who were determined to have the disease or the illness, have the virus, were in isolation, that nearly 17% of the computer keyboards were contaminated with the virus. Now, when they tested a lot of other surfaces throughout the hospital, the good news is that less than 1% of those surfaces were testing positive, but the conclusion that the authors came to was that it was the computer keyboards, which were very easily overlooked by routine cleaning, which ended up being the reservoirs for the virus. And so I've got all the we've got all the URLs up on whoopsie daisy, up on the screen. I probably shouldn't have clicked through to the paper. So in any case, we'll just pull this up and move on to the next thing. So if I don't click the hyperlink, we're not going to open it up, but all of these references are going to be at the bottom of the live stream, and you'll be able to download and click through and drill into the fine detail covered in a lot of these publications. So now if we go on to another publication, and if this one was also looking at rooms used by 3 patients who were tested and found to have the virus. And what the scientists were looking at was what the impact of routine cleaning was on the transmission of the virus. It's a very important paper. It came out maybe nearly 2 months ago now. And what they did is that samples were taken before cleaning, and they discovered that 87% of surfaces, including the air outlet fans, were positive for the virus. Furthermore, other areas and surfaces were tested, including, importantly, toilet areas, light switches, chairs, window glass, and the overall level of contamination was found throughout this area of the hospital to be 61%. Now, the conclusion was that respiratory droplet spread and fecal shedding was responsible for this environmental contamination within the built environment. And again, here's the URL, which I'm putting down at the bottom of each of these key takeaway points so that you can download these articles, read them for yourself. This will become very important for businesses to be aware and do their own research into what they can do and what other academics have said about the probability of surfaces being contaminated in their workplace. Now, what's the third article which I want to review? Well, this one was investigating a university medical center, and they were looking at the impact of viral shedding into the air, but also on surfaces, and they discovered that the quarantine rooms, nearly 77% of them had elements in the environment which were contaminated, and they were typical things like mobile telephones, iPads, mice, TV remote controls, glasses, reading glasses, exercise equipment, and especially the rims of the toilet seats. Now, 81% in fact of the toilet seats were positive, 75% of the bedside tables, and nearly 82% of window sills. That means that there is a considerable amount of settling, just like we see with fungal spore distribution within water-damaged buildings. And interestingly for the virus, 80% of the ventilation grates and 100% of the floors tested positive for the virus. Now, the conclusion was that disease spread was a combination of person-to-person droplet transfer as well as indirect contamination with contaminated objects and possibly being made worse by airborne transmission. And again, here's the link to the paper that I'm referencing. Again, all of these are in my references in my paper as well, but it's important to put them up here too. So let's get on to the fourth key point. What's the stability of the virus SARS-CoV-2 on surfaces? Well, the viability of SARS has been found to be approximately 3 hours into the air. And now that's really, really important because that's one of the key reasons why people have been encouraged to perform social distancing and also to wear masks where they think it's appropriate to minimize and act as a barrier for the droplet spread, because it can remain in the air suspended just like mold spores for several hours. Now, on surfaces, this particular paper has predicted that the decay of the virus titer, it's much more stable on plastic. It can remain for over 3 days on plastic. It's relatively stable on solid surfaces like stainless steel. Copper, a well-known antimicrobial, it doesn't remain very viable on that. And cardboard, the virus can remain for 1 to 2 days. Now, companion testing in this paper, again, I'm going to put the URL up at the bottom of this slide, is very important. They were looking at the decay in which taking whether it could actually infect other cells. And so that's what this TCID 50, very important measurement for virus viability, and they demonstrated stability from very high stability to low stability. They found that plastic retained viability for the longest, followed by stainless steel, followed by cardboard, and copper basically had the best surface. But as we all know, copper is not commonly found, although there has been some excellent research conducted at Swinburne University, which is able to apply copper to high-touch surfaces. So I suggest that you check out the Swinburne University website for more information about their breakthrough method of applying copper to high-touch surfaces like door handles and push plates. And the take-home from this particular piece of research was that aerosol and surface transmission is very plausible, and that the SARS-CoV-2 virus can remain for hours in the air and for days on surfaces. So that needs to be borne in mind. That's the URL for the paper, and you can read more about in greater detail there. Now, what is the number 5 thing that I wanted to tell you about? It's right in the middle, and I think it's one of the most important things as well. The Singapore National Centre for Infectious Diseases also did a study, and they sampled a much larger number of surfaces in their environment, 245 to be exact, and they found a much higher percentage of distribution of the virus within the built environment. And they found that nearly 57% of rooms had at least one surface that was contaminated. So as we consider making workplaces COVID safe, as well as our homes to be COVID safe, we need to consider that it is a very low level of contamination which might be present. And that means that there needs to be a lot greater attention paid to the mechanics of carrying out cleaning to make sure that disinfection does get to everything that could possibly be contaminated in a room. What else did this study show? Well, again, it showed that toilet seats and flush buttons are highly contaminated in nearly 20% of samples, and that high-touch samples were seen in nearly 67% of samples in the first week of the illness, but only 20% of surfaces by the second week of illness. So you can see that there is a reduction in the shedding from symptomatic and I assume asymptomatic patients as well into the built environment that they find themselves in. And so the conclusion from this research was that the first week of illness is the most important, and that's when surfaces become contaminated with the virus. And again, here's the link to the paper so you can read all about it there. Now, what's the 6th important feature that you should be aware of about virus in the environment? Well, the stability of the SARS-CoV-2 virus has been simulated under controlled conditions. And this is a very important paper because they found that the virus is highly stable at cold temperatures 4 degrees Celsius, but is inactivated at 70 degrees Celsius after 5 minutes. But what they did in the simulation is that they got a very, very fine droplet, 5 microliter droplet of the virus, and they inoculated it onto various different surfaces. And they found that no infectious virus was recovered on paper or tissue paper after 3 hours, wood, cloth after 2 days, glass and banknotes after 4 days, stainless steel, plastic and the inner layer of face masks after 7 days, but the outer layer of face masks, the virus remained infectious even after 7 days. So you can see that there's a wide range of viability for the virus on different materials, and that's why these studies are so important, because they allow people to extrapolate from this data to their own situation. And the conclusion from this research was that while specific therapies are lacking, and while there isn't a vaccine available, that early containment of people and following strict infection control principles is the only option to preventing or minimizing harm from the virus. Again, here's the URL to the CDC government website which published this research. I want to move on to the 7th point I want to make. And this is a very interesting paper that came out of China, and they were looking at the clustering distribution of the outbreak size. So how many people, in a sense, cluster together when there is positive identification of a susceptible person who has the COVID-19 infection. And they looked at this issue across 320 cities, and they found that 54% involved 3 cases, 26% involved 4 cases, and less than 2% had more than 10 cases. What do I mean by cases here? Well, outbreaks at home were found to be the dominant method of infection at nearly 80%, followed by people accessing transport at 34%, 4.4% got the virus at a restaurant or a food outlet, 2.2% at an entertainment venue, and 2.2% at an entertainment centre or shopping centre or mall. Now, larger outbreaks were highest for shops and food venues. There was only a single outbreak from the outdoor environment. And that's really, really good news, even from this study, because last week we were looking at the relationship between particulate matter air pollution and not only the impact that that pollution has on inducing mold allergy, but the relationship between particulate matter pollution and the clustering seen in the COVID-19 cases, where more polluted areas with higher levels of PM 2.5 and 10 showed much higher numbers or clusters of individuals who had come down with this particular virus illness. And so it's important that this other piece of research which suggests that the outdoor environment isn't that significant, that's really good for all the people who want to do daily walks and exercise outdoors, because it's important to maintain physical fitness whilst people are in isolation or self-quarantining, and as restrictions are eased in the coming weeks to months. Now, the conclusion of this particular research was that crowding in shared indoor spaces is a major infection risk, and a lot of effort needs to focus on improving indoor air quality, which on this live stream and show I go on about week after week, that indoor air quality, because we spend so much time in the built environment, should be everyone's number one thought for controlling their exposure risk. So especially if you've got water damage and mold, now's the time to do something about that as well. Now, here's the URL to this particular paper. Now, the 8th point I want to make is, how are we going to prepare for easing of lockdowns? And this is what the senator was quoted as talking about in the newspaper this morning. And there is going to obviously be a significant need to reduce non-contact surface transmission. And in the paper I wrote and published, I have listed the recommendations for surface disinfectants, because there are a lot of disinfectants which are likely to work for SARS-CoV-2, and there are a lot of suggestions for cleaning methods that may not work at all and don't have any good evidence or scientific basis for efficacy. And again, in previous live streams, we've talked about the List N produced by the US EPA and their list of recommended disinfectants. So I suggest that you go back to some of my earlier live streams for that, or download the paper and read about the research into practical disinfection methods. But I want to make the point now that lowering the level of surface contamination, the reason for this is to bring this down. This is this concept of flattening the curve. We need to make sure that people don't inadvertently become contaminated by coming into contact with contaminated surfaces. And the recommendation in the academic literature is to take active measures to reduce air and surface contamination. This publication focuses on surface contamination. Now, other academics that I cite in my paper focus on the risks from premature withdrawal of a lockdown, because this could lead to reactivation of the virus through either of the two transmission routes: direct contact, or this concept of indirect contact, which is touching something which has been contaminated. And so the conclusion was that any exit policy must take into account transmission reduction steps for both pathways, direct and non-contact or fomite transmission. This is the surface contamination problem. And here's the publication up here, again from the CDC. You can download that. Now, there's two of them, because one's looking at risk reduction from easing lockdowns and what policy makers should be considering. So that's why I've put both up here. Again, you can get all the references and more in my paper. Now, what's the ninth thing I want to talk to you about? Well, you're probably wondering, if you've been watching this far into the live stream, how are you going to actually screen in the environment for this particular virus? Well, this usually involves swabbing suspect surfaces, and then using something called PCR, or the polymerase chain reaction. And this is a method of quickly amplifying the number of copies of a target gene in order to determine whether or not there are any DNA fragments or residue of this particular virus in the environment, on surfaces, of course. And a positive result is going to be seen when the test fluoresces. And that means that the material has been successfully amplified under PCR. Whereas, if no genetic material for the virus is present on those surfaces that were swabbed, no amplification is going to occur, and therefore no fluorescence will be seen. So swabbing is going to give you a yes, it is contaminated, or a no, it's not contaminated. And that's the type of binary answers which businesses are going to want to implement so they can validate their cleaning methodology. Or if they do discover the virus, that they can quickly act on that and contact trace individuals that could have come into contact with those surfaces, and then improve their policies and procedures for routine cleaning. Now, the 10th point and last point I want to make, you're probably thinking, well, now what? Well, this concept of testing in the built environment, is called environmental surveillance, and it is really important and needed to optimize hygiene and detect the virus early so action can be taken as required. You're probably thinking, well, what exactly is it? Well, it's all those steps, carefully scanning your work practices and the built environment that you work or live in, and doing something called risk management. That's the definition of environmental surveillance. And this is going to include reviewing and updating policies and procedures, implementing site inspections, implementing cleaning audits, reviewing the best practices being done worldwide as everyone moves from lockdown to reduction in social distancing and moving back into a more normal way of life. So people will need to spend a lot of time considering their role and responsibilities in the workplace and home to protect yourself, and in a sense, like the insurers say, mitigate your loss. So once a surface has been confirmed to be contaminated, or the probability of contamination is high, then environmental cleaning and disinfection really becomes absolutely mandatory. Now, which businesses or activities do you think are most at risk for surface contamination? I'm sure you've got your own ideas, and essentially we are doing another paper with some collaborators, and this is going to be a survey looking at the knowledge and perceptions of environmental surface contamination in the United States, the UK, and Australia. We are soon to release this survey. We would love your input. Even before this survey goes online for data collection, I'd urge you to send through your interest by making a comment on this video, either on Facebook, YouTube, Instagram, or Twitter. And that way we will be able to get some really interesting data about your feelings and perception about surface contamination in the built environment, and what your role and responsibilities and how you should be thinking about this topic. In any case, my name's Dr. Cameron Jones. I hope everyone is thinking about how they are going to prepare for moving out of lockdown, and how they can proactively get on the front foot to make their home and workplace COVID safe, because social distancing will end sooner rather than later, and it will then be every person's responsibility to do the right thing and do whatever they can to minimize their own exposure and the exposure of their clients and stakeholders and the wider public. In any case, I do these live streams each week. This podcast will be up on themoldshow.com later today. Stay safe and have a great week. Bye for now.